Number 47, solve the problem, and we're told to assume the cost of a car is $18,000. With continuous compounding in effect, find the number of years it would take to double the cost of the car at an annual inflation rate of 3.8%. Round the answer to the nearest hundredth. All right, so very similar to number 45 and 46 that we've looked at. We are starting with a car that costs $18,000, and we need to find out how many years will it take for this car to go from $18,000 to, well, if we're doubling the price of the car, or the cost of the car, 18,000 doubled is 36,000, right? So how long will it take the cost of this car to go from $18,000 to $36,000, assuming an annual inflation rate of 3.8%? Well, again, we're going to be using PERT. We know that A is the compounded amount, so the amount at the end of this period, the amount that we're stopping at. Well, 36,000 is the doubled amount, equals P, our principal, our starting amount, 18,000. E, again, Euler's number, to the R times T. Well, R is the inflation rate, 3.8%, but we know that we have to write 3.8% in decimal form, so we'll have 0.038 times T, time, which is what we're solving for. So here we have it, 36,000 equals 18,000 times e to the 0.038 t. Fair enough. Let's go ahead. Let's divide by 18,000 on both sides to clear the coefficient here. So on the right, that 18,000 goes away. Here on the left, 36,000 divided by 18,000. Well, that just becomes 2, nice and easy, equals now e to the 0.038 t. We're dealing with Euler's number, so let's go ahead and take the ln of both sides, the natural log of both sides. I'm going to move this over a little bit. So we take the natural log, that gives us ln of 2 equals, and now that I've taken the ln here on the right-hand side, we know that this exponent can move down out front, can it? So that becomes 0.038 t to the ln of e. But like before, we know that ln of e is 1, so we can go ahead and get rid of it there. We want to solve for t, get t all by itself, so we're going to divide by 0.038 on both sides. Here on the right, it cancels, and so we're left with t is approximately, I don't know, let's find out. Oops. So we'll clear that calculator, and we're saying the natural log of 2 divided by 0.038 gives us 18 point, and we're rounding to the nearest hundredth, so 18.24 years. Alrighty, again, all this is telling us is that if today a car costs $18,000, assuming an annual inflation rate of 3.8%, it will take 18.24 years for that car to cost $36,000.